Okay, so on your do now, it says, are the two triangles similar to each other? The answer is going to be yes. The reason is because we have vertical angles. Angle ABE is on angle CBD are vertical angles. So those two angles are equal to each other. And then if I check for the sides and see if they're proportional, if I divide the numbers, 27 and 18, show your proof here, 27 divided by 18, that happens to be equal to 36 and over 24. I just checked to see if these corresponding sides are proportional to each other. And when I do this and I reduce both these fractions, I end up with 3 over 2 for both of them. Now remember, if you do 18 over 27, then you just do 24 over 36. It doesn't matter what goes on top and what goes on the bottom as long as you pair up the right sides and then you look at the two triangles. So if you flipped them over, you get 2/3. So I know that these two triangles are similar to each other. So to write a similarity statement, I'm going to call, let's say, triangle ABE similar to, if I call the first triangle ABE, I have to call the second triangle DBC. These two triangles are similar to each other by the SAS. I think we called it a postulate. No, theorem. By the SAS theorem. And if I was doing a super good job, I would write down somewhere on here, angle ABE is congruent to angle, probably should go down here in our proofs, but here it is. It's congruent to angle CBD because they're vertical. About special segments and similar triangles and their proportional parts. It sounds like a lot, but it really is really easy. So when I look at my first theorem I have here, I have this thing. I'm going to tell you that these two triangles are similar to each other. Triangle ACB is similar to triangle FHG. Okay, if these two triangles are similar to each other, you already know that all the corresponding sides are what we call proportional to each other. Well, all the sides are proportional, but I'm going to go one step further, and I'm going to say that since all the sides are proportional, when I draw in my altitude in these two similar triangles, my altitudes are also going to be proportional to the corresponding sides. So the altitudes are also proportional to the sides. So what this means is, if my triangle, if the side lengths become half the size, so if I look at one side length of one triangle and the corresponding side length of the other triangle, and they're half of each other's sizes, then the altitudes are also going to be half the size. If the triangle gets 3 times bigger, then what's the length of the altitude going to do? The altitude's going to get 3 times bigger. Okay? Same thing goes if I have two similar triangles and I draw in my angle bisectors. These are angle bisectors right here. If I draw in my angle bisectors, those angle bisectors are going to be proportional to the sides. So let's copy this down here and put it down here. So when you set up your proportions, we can just add now in the angle bisector length. When I go look at this, I'm given a bunch of medians. So here's my medians. CD is a median and YZ is a median. Guess what? These two triangles are similar. If these two triangles are similar, all the sides are proportional. And what does that mean about the medians? The medians are also going to be proportional to the sides. Triangles that are similar now. I have one triangle. And what happens when I draw in the angle bisector on one triangle? It splits that triangle into two triangles. When I look at these two triangles, there's only two sets of sides that are proportional. KM divided by ML is proportional or equal to JK divided by JL. To match up corresponding parts. Well, you just so happen to be given the altitudes of the two similar triangles. So I can take the two altitudes and divide them. I can do 16 over x or x over 16. Depends on what you want to do. I'm going to do big triangle divided by little triangle. So 16 divided by x. I'm going to set that equal to, what are my proportional or my corresponding sides? 20 and, yeah, so I'm going to do 20 over 15. Okay, cross multiplication to solve for x. 20 times x is 20x. You bring down your equal sign. And then what's 15 times 16? Fifteen times 16. Okay, 240. And then last step, divide by 20 on both sides. So you get x equals 12. There are lots of ways to get x equals 12. This is one method, setting up a proportion. So the next example is like the same exact thing, except for now you're given a median. I know these two triangles are similar to each other because I have two sets of angles that are marked. So by angle, I know these two triangles are similar to each other. So if I want to try to solve for x, I have my two medians, 13.5 and 9. I could take those two medians and make a fraction or a ratio out of them. 13.5 divided by 9. And set that equal to, now a lot of my kids today have been doing x over 3, which x over 3 is perfectly okay, but the rule says the side lengths. So this is actually 2x, and this side length right here is actually 6. So we would put 2x over 6 on the right side of the equal sign. This is called a proportion. Now, if you put x over 3, that's fine because 2 over 6 reduces to 1 over 3. So when I cross multiply, I get 2x times 9. I get 18x equals, and then 6 times 13.5, 81. Divide both sides by 18. And you end up with x equals 4.5. If I asked you for the scale factor, all the scale factor is one of these ratios. Pick one. I'll pick the orange one, 13.5 over 9, because that was already given to me. When I come and put that in a calculator, 13.5 divided by 9, you get 1.5. So depending on which way you're going, 1.5 is 3 halves, right? So the triangle is either getting 1.5 times bigger, 3 halves bigger, or it's getting, if you're going from the big to the small, it's getting 2/3 the size. The side lengths are. So scale factor is 1.5 or 2/3, depending on which way you're going. That's just a little added bonus. Okay, this one's different than the other two because this one is not two similar triangles. This is one triangle and I drew in an angle bisector. Whenever you have one triangle and you draw in an angle bisector, what it does is it splits this triangle into proportional parts. The parts that are proportional. X divided by 13, I take the two sides. I do X divided by 13. And then I set that equal to, X came from the triangle on the left side, so I need to use 4 on top over 6. These parts are proportional. And then I just do all my cross multiplication. And what did you guys get for your answer? You get a long decimal, 8.6666666. So that's 8 2/3, but a better answer would be 26 over 3.
Why would you want us to put it into a number in a fraction?
So there are lots of ways that numbers can look, right? You can have your decimal version, you can have a mixed number, or you can have an improper fraction. So part of what I'm kind of trying to do for you guys is to think about, I know what you guys are going to need for like algebra 2, algebra, pre-calc, calculus, not so much chemistry, but physics definitely. They're all going to deal with improper fractions. So we might as well just get used to doing improper fractions now, so that way when you get to those subjects, everything just flows really easily. Okay, now the hard one. Same exact problem as the one before this. You have an angle bisector. I don't think any of you guys got to this question yet. Okay, perfect. The easy part, I match up the sides, 11 and 14. Set up a ratio. Equals. But the two parts that get divided, the corresponding parts that get divided on the other side, are this thing, this side length, which we don't know, and X. So we know we're going to have something divided by X. Well, if I draw this line out here separately, and I know this part from here to some point, we don't really know where it's at, that's something, we don't know. And then the distance from that point on is going to be the value of X. And you guys know this whole thing equals 20. Oh, okay, I like it. This question mark has to be whatever is left after you know what X is, right? So what if X was 5? The question mark would be 15. If X was 8, the question mark would be 12. If X was 13, the question mark would be 7. Every single time what you're doing is you're taking the number 20 and you're subtracting whatever X is from it. That gets you the question mark. So this piece right here, the length of this piece is 20 minus X. So in my fraction, I'm going to delete my question mark, and up there I'm going to put 20 minus X. So now we just multiply 11 times X, which is 11X, equals, but when you do this cross multiplication, 14 times 20 minus X, that's 14 times the entire quantity, 20 minus X. And then you distribute your 14. So you end up getting 280 minus 14X. When you do all your algebra, you get X equals which is 11.2.